Solid-state batteries are the buzzword in the battery landscape right now, hailed as the game-changing technology that could transform electric vehicles and portable gadgets. But do they live up to the hype? The answer isn't entirely straightforward yet. A recent breakthrough from TDK Corporation, a leading name in the electronic sector, might just change the narrative. They've unveiled a groundbreaking material for solid-state batteries that boasts an incredible 100 times higher energy density than current options. This innovation could be revolutionary. Picture electric cars that can cover significantly longer distances on a single charge, or smartphones that can go days without needing to be plugged in. It's an exciting vision, but there's more to unpack. So, how did TDK pull this off, and what implications does it have for the EV industry? Let's dive in and explore. For electric car drivers, the worry of running out of battery before reaching their destination, known as range anxiety, is a major hurdle when considering a switch from gas-powered vehicles. Fortunately, TDK's latest advancement shines a hopeful light on the future of EVs. Reminiscent of the brand's iconic cassette tapes from years past, TDK has developed a new type of battery technology, a solid-state battery. Unlike traditional lithium-ion batteries that use a liquid electrolyte, solid-state batteries rely on a solid material for their internal workings. The solid-state design holds the key to the breakthrough. TDK's innovation boasts a massive leap in power compared to their previous attempts. Imagine a car battery that acts like a supersized gas tank, allowing you to travel much farther on a single charge. This new battery packs a whopping 100 times more energy than its predecessors. Placed inside a smartwatch, the new battery could keep a device running multiple times longer than current battery technologies. The Apple Watch currently lasts up to 72 hours in low-power mode before it needs recharging, meaning it could potentially last several weeks with an improved battery life. Other potential applications beyond wearables could include environmental sensors. According to TDK, while the initial application of this technology targets smaller devices like headphones and smartwatches, the ultimate goal is to scale it up for electric cars. With this powerhouse battery, electric vehicles could potentially travel a staggering 1,500 kilometers, 930 miles, on a single charge. That's more than 3 times the range of most EVs on the road today. This significant improvement would drastically reduce range anxiety and make electric cars a far more appealing option for drivers who frequently travel long distances. The benefits extend beyond just range. Solid-state batteries boast a safety advantage because they eliminate the risk of flammable liquids present in traditional lithium-ion batteries. Additionally, they may offer much faster charging times, significantly reducing the time spent waiting at charging stations. This translates to quicker commutes and less disruption to daily routine. Neurosat, the CEO of TDK, isn't shy about his enthusiasm for the company's breakthrough. He envisions their newly developed solid-state battery material playing a pivotal role in a large-scale shift towards a more sustainable, energy-efficient future. This solid ceramic acts as a bridge for lithium ions to flow between the battery's two components, the lithium alloy anode and the cathode. While this solid approach offers significant advantages, it also presents some technical hurdles. Maintaining a stable connection between the solid electrolyte and the electrodes proves more challenging compared to liquid electrolyte. Additionally, the entire battery needs to operate under pressure, adding another layer of complexity to the design and manufacturing process. The request for a powerful solid-state battery isn't a solitary endeavor. Major car manufacturers, particularly those from Japan, have been vocal about the immense potential of this technology. Toyota, for instance, has been heavily invested in in-house battery development and aims to bring solid-state batteries to market by the end of 2027. However, this target date has shifted from earlier projections, highlighting the unforeseen challenges encountered when scaling up this new technology from a lab to mass production. The mechanical complexities involved in building large, robust, solid-state batteries for electric vehicles have proven to be a significant obstacle. And the future of solid-state batteries? A new type of battery design called semi-solid state has emerged. This technology offers a stepping stone towards the ultimate goal. Chinese automaker NIO exemplifies this approach, offering semi-solid-state batteries as an option on their ET7 sedan. These semi-solid-state batteries boast an impressive advertised range of 1,000 kilometers, a significant improvement over current electric vehicle offerings. The development of solid-state battery technology is a race against time, with companies like TDK and car manufacturers like Toyota vying to be the frontrunners. While technical hurdles remain, Breakthroughs like TDK's new material and the emergence of semi-solid-state batteries offer a promising glimpse into the future. We're on the cusp of a transportation revolution, with electric vehicles powered by safe, long-range, solid-state batteries becoming a reality. This shift has the potential to drastically reduce our dependence on fossil fuels and pave the way for a cleaner, more sustainable future for our planet. When should we expect to see TDK's new battery in the market? The road to widespread adoption of solid-state batteries may be longer than some initially anticipated. Romotion, a consultancy specializing in the battery market, throws some cold water on our enthusiasm, suggesting that we might not see this technology reach the mass market until 2035. This delay is primarily driven by cost. Solid-state batteries are even more expensive to produce than their lithium-ion counterparts. While a typical EV battery currently accounts for roughly 1/3 of the entire car's cost, the figure jumps to a staggering 50% for the Neo with its semi-solid-state battery, and the price would likely be even higher for a pure solid-state model. Iola Hughes, a Romotion analyst, sheds light on the reasons behind this delay. Solid-state batteries have been a topic of intense interest within the battery industry for quite some time, she acknowledges. However, a consistent theme has emerged: delays and missed targets. The reality, Ms. Hughes explains, is that progress is happening incrementally. While the technical advancements like TDK's new material are exciting, the major hurdles lie in cost and scalability. Manufacturing these batteries needs to become significantly cheaper and more efficient before they can truly compete with lithium-ion technology. Solid-state batteries also face some technical challenges that require further refinement. One concern is the inherent brittleness of the solid electrolyte material. This brittleness has the potential to negatively impact the battery's lifespan, especially during repeated charging and discharging cycles. Additionally, solid-state batteries tend to perform poorly in cold temperatures, which could limit their range and effectiveness in certain climates. Despite these challenges, Ms. Hughes highlights a potential niche where solid-state batteries could offer a significant advantage. Electric-powered heavy trucks, for example, may not be well suited for lithium-ion technology due to the limitations on range and charging time. Solid-state batteries, with their potential for longer range and faster charging, could be a game-changer for the electrification of heavy-duty vehicles. Solid-state batteries are considered safer due to the absence of a liquid electrolyte, which is a potential fire hazard in traditional lithium-ion batteries. The use of solid materials in the battery's construction enhances its stability and reduces the risk of thermal runaway, making it a more reliable and secure option for powering electric vehicles. The potential impact of TDK's breakthrough extends beyond individual consumers to the automotive industry as a whole.